So in this video, I wanted to talk about welding. So in the PE handbook, there's not really any overarching equations for this, but there are several different charts that'll have unique equations for different geometries of welding and different ways of loading. There's the key word for this section is welding, and there's two main charts. There's one that talks about the types of welds, and then there's another one that talks about the bending and torsional properties of fillet welds specifically. So I just want to jump right into an example here. So a 4-inch wide by 6-inch tall steel plate is welded on each vertical side, this should be 2, to a rigid support. The shear strength of the weld is 10,000 psi. If the plate is to be loaded with a torsional load of 38,000 inch-pounds, what size of weld is required? Round your answer up to the nearest eighth of an inch. Use the provided table for reference. Okay, so this is one of those tables, or this is actually part of this table. It spills over onto a second page, but this is the relevant one. So we need to know basically how much material, how thick does that weld bead need to be. So we're loaded here in torsion, which is going to be 38,000 inch-pounds. And so based on that, if let's say this was not a weld and you were just twisting a beam, you'd be looking for the shear stress, and it's going to be a very similar idea to that. And in fact, it's going to be the same equation. So the shear stress is going to be equal to the torque times the radius divided by the polar area moment of inertia. But for welds, the radius and the polar moment of inertia are going to be slightly different. So for this case, the radius, the r, is going to be the distance from the centroid to the furthest point along the weld. So it's going to be in one of these corners, any 4 of those corners. So we want to know how far is it from the centroid of the weld group to the furthest away corner. Now this is a pretty easy weld shape because the centroid is just going to be right in the center. If we had one of them like this where it was welded on 3 sides, then your centroid would be offset a little bit. But this should be pretty easy to find. So basically we have 3 inches and 2 inches because we're cutting each of those in half. Then our r, so r is 3 squared plus 2 squared. Which is going to be 3.606 inches. Now for J, it's a little bit trickier. So you'll see it has a column here that gives you the unit second moment of area. And if we find our type of weld here, which is the 2 vertical beads, then we have this equation, which is J sub U equals D times 3b squared plus d squared divided by 6. D is just the height of the weld, and B is how far away they are from each other. But this is not the same as this. JU does not equal J. And I really wish that this table made that clear. So down here at the bottom, we have this, which is for just the regular area moment of inertia. They say is equal to this 0.707 times h, which is the thickness of the weld, times the unit moment of area. And it's the same idea for J. So J is 0.707 times h times J sub U. I really wish they had this formula down here, but unfortunately they don't, and so that's just one you're going to have to know, or at least know it's the same type of equation as that. So JU is going to equal 6 times 3 times 4 squared plus 6 squared divided by 6. That's going to be 84. That's in inches cubed. So now, if we fill in our values in this equation, we have our shear strength that we need to reach 10,000 psi, and that's going to be equal to 38,000 inch-pounds, times the radius that we found, which was 3.606 inches, and divided by our polar moment of inertia, which is the 0.707 times h times our j sub u. And we're solving for this h, so if we rearrange that and plug in these values, we get 0.23 inches. And this question asks us to round that up to the nearest 1/8 of an inch. So that means the weld is going to be 1/4 of an inch. The trickiest part about welds is knowing how to use these tables. You got to practice using the tables. But once you know how to use them, it's really not that hard, and it gives you all the equations. You just make sure you find the right type of weld, and there's 3 more that it gives as options on the next page. But yeah, and understand what the throat area is, which the throat area is like the, if you're looking at the weld, it's sort of the cross-sectional area, but not exactly. It's that one is kind of hard to explain what exactly that one means. But yeah, know how to use this table, and you should be good to go. Just remember, this is the keyword is welding, and that's how you are going to find this table. But yeah, I hope this helps.